Florida's beaches have always been playgrounds. When my parents moved to Miami over 50 years ago, my sisters would play in the sand just as kids do today. My favorite beach was Matheson Hammock Park Wading Beach. We explored Biscayne Bay's tidal flats and splashed through gentle waves that barely reached our knees. My family used to come here and we'd picnic right here on this beach. We'd have our fried chicken and then the kids, we'd wade out into the water. Today, the tide covers the old picnic spot and flows across the road where my dad once parked our 1958 Plymouth. What happened to my old playground? Was it a hurricane? Is the land sinking? Or is this place of my heart a victim of some even larger event? A short distance up Old Cutler Road from the park, I met Dr. Hal Wanless of the University of Miami. He said there was something living under a bridge that might give me a clue as to what happened to my beach.
Here you can see barnacles and, of course, oysters that live in the intertidal zone. And we have photographs from here back in about 1949 taken by some marine science students. And if we compare those with photographs taken in 1980 and today, we simply see that both the intertidal organisms, the barnacles and the oysters, have been moving up. These show exactly the same thing that the tide gauge records in Miami, Key West, Naples, around South Florida show, that we have had about 7/10 of a foot rise in sea level since about 1930.
That's 8.4 inches, and that's 6 inches in the last 50 years, and that explains a lot. The wading beach was barely above high tide when I was a kid. Matheson Park is a mangrove hammock, and Dr. Wanless said when mangroves are knocked down, their roots collapse and the ground above them sinks.
After Hurricane Andrew, we were recording subsidence rates of the mangrove substrate through root decay of 2 to 4 centimeters per year.
Dr. Wanless is a professor of geology and a researcher studying the effects of hurricanes on the coasts. He pointed out that the main problem with my favorite beach and beaches around the world is the rising sea. And although the sea has been rising for about 6,000 or 7,000 years, ever since the glacier that once covered much of North America began to retreat,
we're running now since 1930 at a rate of a foot per century. That rate is about 8 times faster than the average rate that sea level was rising for the last 2,000 years for South Florida. A rate of a foot, 30 centimeters per 100 years is close to catastrophic for a place like South Florida.
in the summer, the professor takes his geology students to Labrador on a field study expedition. The locals there say that 50 years ago, they may have seen 2 icebergs float by in a season. Now they see thousands.
Sea level can rise by putting more ice cubes in our ocean, icebergs that come off Antarctica or Greenland. It can also rise by warming our waters in the ocean. And that's in fact seems to be what's been happening over the last 70 years. The surface waters of the oceans have warmed a little bit, but more importantly in the Atlantic, the formation of our deep ocean water, the deep ocean water for the world that forms up on either side of Greenland, that deep water that's forming has gotten less saline and I believe a bit warmer. And as a result, the deep water that's forming is expanded. And that water moves south through the Atlantic, and that is sort of swollen our ocean. What's forecast for the next century is another 2 foot of sea level rise. It's estimated that a foot rise of sea level, again, we've had over 3/4 of a foot in the last 70-some years. A foot rise of sea level can be expected to cause about 500 to maybe 1,000 feet of erosion.
Just down the road, Matheson Hammock is on the front line of the relentless march of the sea.
It doesn't take much of a rise in sea level with such a low gradient to dry the water very far inland, and so this area floods considerably during spring high tide.
I want to know what is causing the sea to rise.
There's really no question but the Earth is warming up. I mean, that was debated for a while, but no serious scientist really debates that anymore.
As I stood with Dr. Stephen Leatherman, Director and Chair of the Laboratory for Coastal Research at Florida International University, and watched water wash across a once dry road, I asked what evidence he saw of human influence on the climate change.
If you look at all the records, we're going up so fast, our temperatures are going up so fast. We've had some of the last 10 years, we had something like 6 or 7 of the warmest yearly records ever on history in the last 100, 150 years. So clearly we're going up the temperatures are going up very fast. We also know, of course, know that we're burning tremendous quantities of fossil fuels, oil, gas, coal. All that adds carbon dioxide to the atmosphere, so-called greenhouse gas. And those gases are really trace gases. They amount to less than 1% of what constitutes our air. Most of our air is nitrogen, something like 70%, oxygen, something like 21%. But these trace gases, carbon dioxide, methane, another greenhouse gas, and water vapor, these are the gases which actually make life possible here on the Earth. So that's the good news. In other words, without the greenhouse gases, which act as a thermal blanket, we would really be too cold to live on. But it's a very sensitive regulator. Here are the gases that only are, again, trace gases, less than 1% of the atmosphere, but they control our Earth's temperature. So we're increasing these gases by a huge amount, adding billions of tons of carbon dioxide to the atmosphere every year, and that causes the heat to be trapped, and therefore the Earth is warming up.
The term greenhouse effect was coined in 1896 to predict the warming of the Earth caused by the burning of fossil fuels and the pumping of carbon dioxide into the atmosphere. So the water in Biscayne Bay is rising. The land around New Orleans and on parts of the East Coast is sinking. Could the land in South Florida also be sinking?
Here in Florida, we don't have much land sinking, and that's the good news, because we're mostly sitting on a rock. I like to tell people I live on a rock here in Florida. The peninsula is a rock. It's an old coral and carbonate structure.
Millions of years ago, the southern tip of our peninsula was a string of islands along the middle of what is our state now, around Lake Wales. Back then, reefs were growing where we live now. Those reefs turned into a limestone known as Miami oolite, and that is what much of our state is resting on today. As I'm leaving Matheson Hammock Beach, I notice another rather ominous change that's happened since I was a kid. The North American crocodile is an endangered species, and I'm all in favor of protecting threatened animals. Crocodiles are different from alligators in 2 important ways. Crocs live in saltwater and are more aggressive than gators. And that's why I decide it might be safer to wade through the water from my car. Pneumatophore roots near the asphalt are evidence that the mangroves are on the move. Sometimes called island builders, mangroves grip our natural coastlines. They anchor the land. I suspect that changes to the mangroves can tell me more about sea level rise in South Florida. And so I joined Dr. Tom Smith, a research ecologist with the U.S. Geological Survey.
Coming up!
Research associate Ginger Tiling, and hydrologic technician Gordon Anderson on a trip to a research site deep in the Everglades. I have been just about everywhere in my native state, but this was a first for me. On the way, I have another first, my first wild North American crocodile. I asked Tom if sea level rise might have an effect on the crocodiles. He told me that if they lose their habitat, the sandy beaches and escarpments of the Everglades, they may have to expand their nesting grounds, and that could mean they head north.
Well, Ed, welcome to Johnson Mound Creek. And we are studying the responses of the mangrove forests to climate change, things like sea level rise, increased storminess.
Mangroves are a good indicator of sea level rise because they live in the intertidal zone, and where it goes, they go.
Obviously, we're in Everglades National Park. We're looking at the impact of the restoration, the Comprehensive Everglades Restoration Program, which is going to be adding fresh water from the upstream side down into the coastal estuaries. And so we have a whole series of study sites where we look at hydrology, we look at the sediments, that's the soils, and we look at the mangrove forest.
It's not a white coat kind of laboratory. While balancing on narrow planks, the researcher takes measurements, and they take note if crab holes add to the readings.
7, 6. These plants, they produce a lot of root material. It doesn't decompose, they form peat. And are they building upwards fast enough to keep up with the level of sea level increase? And that's what we're trying to find out.
Tom is using an instrument to measure the amount the forest floor has gone up or down since he was last here. He calls numbers out to his assistant. He has been checking his 8 sites every 3 months for more than 6 years.
So there is deposition of sediment going on here, but it's still going down. And I think it's going down because of the damage from Hurricane Andrew. I mean, you look at a lot of these dead stems that are here, were all really messed up by Hurricane Andrew.
Tom attaches his measuring device to a pipe driven down to the bedrock. This gives him an accurate reading of how much peat is building on the surface.
But there is another theory that if you have subsurface dissolution of your bedrock, which is carbonate, then you could have bedrock that sinks down.
That is correct.
But it's not really sinking, it's dissolving.
It's dissolving away.
So everything that's above that is going to sink in relation to that dissolution of your bedrock, which here is carbonate or limestone.
And that is probably a process which is going on here because this peat has a lot of organic acids in it, which could be very, very important to the whole coast, southwest coast of Florida. And it's something that is, we know, nada right now.
I mean, some people even dismiss it.
Oh,
but,
yeah.
But I don't know. I think there's something to it. We just don't.
I have a sneaking suspicion there's more to it than we've allowed.
Tom Smith and his team compare the salinity of the soil with that of the river. If the salinity goes up over time, it means the sea is rising into the area.
And as it does, it will alter the vegetation. So inland, where mangroves give way to marshes, you would expect the mangroves to be moving inland. At the same time, what the restoration is going to do is add fresh water from upstream. So now we have sea level coming up, we're adding fresh water from the top, something's got to give in the middle. And in the middle are the mangrove forests.
Also in the middle are the inhabitants of threatened coastal areas. In January of 2004, scientists writing in the journal Nature suggested that climate change could push as many as 37% of all species of life on the planet toward extinction by the year 2050. With the methods they used, the loss of habitat was a primary factor in predicting what will live and what will die. The Florida Keys exist at the mercy of the sea. Today, the key deer are endangered because their habitat is endangered. And some of the evidence is down this trail on Big Pine Key. So this is all limestone. And this is really what the keys are, the lower keys.
That's right. Yeah. It's kind of funny, the tourists come down and they're looking for these beaches and this and that and the clear water and, you know, the whole effect of kind of having a Caribbean vacation, you know, in the Keys. And it's kind of difficult, and they don't really believe you when you tell them there are not hardly any beaches in the Florida Keys. You know, it's basically just, you've got your rock all the way out to the buttonwoods, and then past the buttonwoods you've got submersion where the mangroves start.
Shane Wisnet, wildlife biologist with the Fish and Wildlife Service, showed me how the lower keys are changing.
And as you can see, if you pan to this side, to the left too, you can see this is salt water in front of us, and we're turning into, you know, we've got mangroves, we've got black mangroves, and we've got some whites. And then if we go further out towards the edge of the water, we're going to see red mangroves. You see dead trees out in front of me, and what those dead trees are buttonwoods, and those are species that are supposed to be on a higher elevation and in a different transitional zone. And so basically, I guess this is evidence of a sea level rise into an area that perhaps historically didn't have the seawater here, and so there's an influx of saline water that so much so that it's actually killing the buttonwoods because they're not used to this type of transitional zone and that much salinity in the water.
The key deer, the smallest relative of the Virginia whitetail, wandered onto the Keys thousands of years ago when the ice age we are still in now held a greater amount of the Earth's water supply frozen in ice caps and large glaciers. The deer ranged free until the rising sea created the Florida Keys.
Historically, their range was all the way from Key West back up to, I want to say, just south of Marathon. And so you've got that area that they were in historically, that's where their range was, and now their range has been reduced to basically right around approximately 24 islands. So you've got, let's say, 20 to 25 islands or keys that they still use, and the backbone of those keys that they use are made up of 5 keys, that being Big Pine, No Name, Sugarloaf, Cudjoe Key, and Little Pine Key. You know, how's the sea level rise going to affect the key deer, especially if it let's say it rises in 3 feet and however long, say 100 years. I guess number one, the first effect it's going to have is the amount of livable habitat and land that you have. The Keys are definitely a finite land resource because we're out in the middle of the Gulf and and the Atlantic Ocean, and so land mass and land area, I guess, is the number one thing. Number two, there's a possibility you have an issue of having elevated salinity in your freshwater resources in the pine rockland areas. And like I spoke of earlier, that's a crucial issue for the key deer. That's where they derive their fresh water from. And being a large mammal, they need an open source of water. It would affect, in my mind, I think it would affect some of the forage ability, because if you have it rise that far, you're going to rise into the hammocks that I was speaking of earlier. That's basically a transition from the mangroves, the buttonwoods, and then you've got the hardwood hammocks and then the pine rockland. And the hardwood hammocks hold a lot of woody species that are very important to their forage and compose a lot of their diet.
The deer were hunted until in the 1950s their numbers were fewer than 30. Today, thanks to people like Shane, there are about 800 key deer. But still, people are their greatest threat.
The biggest mortality we see in key deer every year are from roadkills. And like I said, out of 137 mortalities we saw last year, 91 of those, or approximately 66% of those, were from roadkills.
The key deer will probably survive because the ecologists have a backup plan.
Right now we have, I believe, 11 key deer that we have at Homosassa Springs State Park, and those deer were put there. Some of them had issues with, they needed to be rehabilitated after some injuries, and there are also some that were taken there because they had a high load of parasites and also a rehabilitation issue. And I guess as a second addition to that, those key deer are put there in I guess in preparation for that quote-unquote the hurricane that might put storm surges over Big Pine and No Name and significantly reduce the number and basically create a need for a propagation program.
The Keys. They're a funny place. The wonders of nature exist alongside the curiosities of people. Hurricanes threaten yearly, and yet there is still only one road out. That is why the Lower Keys have a moratorium on building, and yet people come here to stand in awe of a sunset at the end of our land. Are they also witnessing the sunset of our natural beaches? The evidence is clear that human activity is pushing the earth to warm and the oceans to expand. If it's our mess, how do we clean it up? How do we face the future? Some cities, like Cocoa Beach, have taken a proactive stand and sent resolutions to the state requesting that they develop a Florida Global Warming Action Plan. Is it too late for our beaches? What does it take to turn this into this?
To get the Brevard County Shore Protection Project underway, it took roughly a decade of work by county and state staff and the Corps of Engineers to do the background work necessary for environmental permitting, economic analysis to determine the best, most cost-effective way to do the project.
It also takes money. It costs $22.4 million to nourish 9.4 miles of beach around the Cocoa Beach Pier. The sand was mined from a shoal 5 miles off Cape Canaveral.
The sand quality was very important to us because it's important to sea turtles who nest on our beaches. So a lot of time and money was spent to get the best quality sand. In return for that, we get very successful turtle nesting on our newly constructed beaches, and we also get beaches which last well to winter storms. So the initial plan was to perhaps have to renourish every 6 years, plus or minus a year or so as needed.
His department also works to save the miles of dunes that act as levees for this part of North Florida.
The ocean erodes the dune and does damage to the dune. The dune is there to protect the upland, and the vegetation holds the dune together, but salt water does impact the dune, so when we make the beach wider, it gives the dune vegetation a better chance to get a good foothold.
As an advocate for Florida's beaches, McGarry favors the way they are currently being managed.
The state has a very active office. The Department of Environmental Protection, Bureau of Beaches and Shores, they have a long-term plan to manage Florida's beaches. That's in place. It's very effective. Florida has dedicated $30 million annually to maintain its beaches. And they count on the federal government's involvement as well as a partner in the process. It's a 50-year project cooperation agreement, and it doesn't specifically address sea level rise. It just addresses the need to protect from beachfront erosion, but the engineers are well aware that sea level rise is part of the equation.
The federal EPA's website says that the sea level could rise another foot by the year 2025, and the Intergovernmental Panel on Climate Change set the prediction at about 2 feet of rise by 2100. Some climate experts think it could rise as much as a meter in 100 years.
Well, 100 years is a long way off, and the difference between 1 foot of sea level rise and 1 meter is quite huge. 1 foot we can manage by continuing to use shore protection projects, beach nourishment, dune construction, but in the long run, if it comes to the stage of a meter or so, the barrier islands just are not tall enough.
Florida's beaches are still the world's playground, but it's obvious you have to pay if you want to play.
The tourism industry is a huge industry, and it generates taxes that support the federal, state, and local government. They are expensive projects, but all 3 of the entities, local, state, and federal, receive significant benefits. And the cost-benefit analysis indicates the benefits are much higher than the cost in the end.
Perhaps it's ironic that a rise in the Atlantic would threaten a major CO2 factory, A1A. Cars and trucks on U.S. highways produce about a pound of CO2 for every mile driven. That's about 302 metric tons of carbon per year. I contribute a couple of 100 pounds of CO2 to the atmosphere driving home. The beach report back home in Sarasota is for the same conditions as everywhere else. According to the State Department of Environmental Protection, 409 miles, or approximately 50% of Florida's beaches, are experiencing erosion. At present, about 299 of the state's 825 miles of sandy beaches are experiencing critical erosion. Well, if the Cocoa Beach nourishment cost $2.4 million per mile, and we have 299 miles of really bad beaches, that's almost $718 million to repair them now. On barrier islands like this one, Siesta Key, the buildings humans have put up have stopped the natural island building process. where storms deposit sand and move the beaches. Experts say we are left with three choices: nourishing the beach with sand, losing the beach by building walls to stop the sea, or planning a strategic retreat and dismantling the structures along the shorelines. The sea may come up another 10 inches to a foot. What would you think about that?
I'd be interested to see the water level marks. I don't doubt it, because I've lived here my whole life and I've watched the water move up over the last 25 years, so I wouldn't doubt it if it does move up.
I don't know. I mean, keep on consuming fossil fuels and making the climate warmer. You know, ice has to melt and go somewhere. So I don't know.
We get a lot of erosion up there. They got to keep on putting the beach back in again. You know, as Corps of Engineers, they take the dredges out and blow the sand back on the beach again.
The bad news is we can't plant enough trees to suck up all the carbon that we've put into the atmosphere over during the industrial period.
It's demoralizing because you've got the keys, it's a finite land resource, and we're out in the middle of an area that has very big issues with sea level rise. And you know, I think the only change you're going to be able to bring about is going to be through kind of a global type change in the type of activities we have, and the different, you know, how we use fossil fuels and our emissions. So yeah, you got to keep on trucking, as they say.
Yeah, exactly. Yeah.
If you look at the map of South Florida and take the coastline, that's the North Shore of Florida Bay, and then the southwest coast, basically the coastline is going to move up almost to Florida City, Homestead area, and up the Shark River Valley, the mangroves will reach up almost to US 41. We have to start to seriously consider both the cost of continued beach renourishment, because everybody seems to want a beach if they live on the ocean rather than just a vertical seawall. And we also need to start to seriously consider which areas we should not let redevelop if the ocean and storms take away the oceanfront property. It's a hard thing to do. It's a hard decision to make. But if we look what's coming with a 2-foot rise of sea level, it's inevitable that a large number of our ocean areas are going to be in serious trouble, and we're going to have to make these kind of decisions in the coming century, and probably sooner.
The cities of Florida may need to redesign in order to stay above water. Stormwater systems may need help. With an appraised value of $1.3 trillion, the Gold Coast from Palm Beach to Miami will get help. The Everglades, that may be a wash.
I hate to say it, but I think what we'll go to is pocket beaches. There'll be large strands where we have to protect the cities on the beach, so we have seawalls. Then we'll have designated sandy areas to come to.
If we plan for the future, maybe we'll meet with fewer shocking surprises. The sense of wonder I discovered at the waiting beach of Matheson Hammock Park is a part of me, although the place I knew has gone beneath the constant waves of change. I can't offer my children and grandchildren the geography of my childhood, but I know they'll find their own.